Good morning, good afternoon, everyone. Welcome to yet another informative webinar by Impetus. I'm Lisa Glenn, your host and presenter for today's session on continuous performance management, the collaborative approach, where we're going to discuss how using a performance-centric development approach can help uncover performance issues early in the SDLC. Today, we have Mustafa Batteriwala from our Performance Engineering Group here at Impetus Labs as our expert speaker today. Mustafa has been involved in the various R&D initiatives and leads the performance engineering engagements for our ISV clients. So let's go ahead and take a look at what today's session has in store for us. Now, as you may know, poor application performance leads to the loss of revenues, customers, and credibility. Organizations can avoid these issues by integrating continuous performance management, or CPM, while developing the software. Repeated performance unit testing and integration analysis assures stability when the application is deployed in production, and the result is a dramatic cost efficiency and reliability in developing those applications. Now, on your screen now, you can see some of the major takeaways that you'll get from today's session. We're going to share with you how you can implement CPM in your software development lifecycle, or SDLC, and the session will also discuss how CPM can be adopted in Agile Environment, its various benefits, and some real-world examples. We're going to be discussing all of this in detail in our coming slides. But in the meantime, let me first just give you a brief overview of the traditional performance testing approach. Technology companies and ISVs have been using the Waterfall approach for performance engineering because, for the most part, it's a well-established and mature process. However, we believe that there are some serious pitfalls along this path. With Waterfall, the performance engineering is conducted at the end of the development lifecycle, just before the product goes live. Now, if in case the performance tests discover any major performance issues, it would involve higher costs and efforts to fix the same, and your woes would even multiply greater if any design and architecture changes are required to fix these performance issues. In such a scenario, very little room remains for performance tuning and optimization efforts. Now, we can address all these limitations by adopting a proactive and agile approach toward performance engineering. And we believe that continuous performance management is that ideal and effective approach. CPM applies the principles of performance engineering to the practice of continuous integration. It really enables you to discover and address performance issues at the early stages of that development process. It can really help in integrating the performance engineering activities with different phases of SDLC, starting from the requirement analysis to design and architecture, to development, to testing, and then finally deployment. CPM advocates performance-centric development, wherein the developers test the code performance right at the method level. CPM recommends extensive automation to reduce the manual intervention and thereby saving cost, time, and efforts. It also enables just a greater cohesion and coordination among various team members at different stages to achieve those common goals. So let me go ahead and share with you some of the details of implementing continuous performance management in SDLC. The first step to this is performance requirement analysis. Now, as I already shared with you, CPM advocates planning for performance right at the beginning of the development lifecycle. Along with business requirements, due emphasis is given to collecting and defining the non-functional requirements. Now, this helps in establishing the performance objectives from the very beginning and really helps avoid confusion or misinterpretations towards the later part of the development lifecycle. I'd now like to ask Mustafa to share with us some of the details of incorporating CPM in this particular stage. Mustafa?
Thank you, Lisa. A very good morning to all our audience. requirement analysis is an important phase in the overall SDLC. This is the phase where requirements are established and we work towards achieving those requirements during the subsequent phases. Now, with respect to the performance engineering activities, the non-functional requirements too are captured during this phase. User performance requirements like response times, availability, throughput are established and defined at this stage. Further, system performance requirements like CPU, memory, and network bandwidth are also defined, which helps in the final deployment stages of the application. It is very important to test the application as it is expected to be used in production. It is not important, or it is very difficult to measure an application that is used indifferently in production and something different in test environment. So we need to come up with our workload models that realistically simulate the production systems. There are various tools that can be used to capture this information and trap them. Different project management tools or requirement management tools in particular, like Quality Center or Pivot, can be used. Even tools like as simple as Excel can be used to create few templates that can be used to capture this important information. Incidentally, we at Impetus have created an Excel template that we use to capture this information while the discussions with our clients. Now, you can see on your screen a sample screenshot of this template. On the left hand side, you can see an important parameter that is often missed by most of the teams. It is very important to capture the year-on-year growth patterns of an application that you intend to test. It helps us in effectively coming up with a performance testing strategy for an application. Further, non-functional requirements like performance, security, and usability are also discussed and prioritized as per the business objectives. This also gives clear objectives to the development team to focus on common goals. You can also see a graph that simulates a peak usage period in production for the sample application. Now, as you can see that the peak window is really limited. Now, if we want to have an effective testing strategy for this, we need to closely simulate this behavior and have the same user distribution and business scenarios in our testing systems. So this helps in coming up with the actual scenarios and test the application accordingly. Lisa, over to you.
Great, thanks Mustafa. Let's go ahead and move on to the second step, which is design, which of course is a very important stage in SDLC. It's also very important to consider performance in this phase. Furthermore, the architecture and design should also be robust and inherently scalable. This will help govern the technologies that will be chosen for development and deployment later on. Let me just give you an example. Say that for a J2EE application, you may choose among the available options, such as Spring MVC and Hibernate, or Struts and Hibernate, or perhaps JSF. So, depending on the performance and scalability requirements you have, we will select an appropriate stack for that. I'd also like to share with you that we here at Impetus have developed a platform named Accelerate that integrates the design and architecture best practices into the software development lifecycle. Now, this platform enables continuous development and helps in reducing the overall development time by suggesting the best suited architecture and design based on the defined requirements. We're now going to move on and discuss development, where we recommend that performance remains the focal area. Here, the developers would be required to frequently test the code for performance and scalability. Now they can create performance unit test cases for the module or user story that's being created. These tests will in turn indicate how the code is performing. They then can verify the code optimizations by running these tests before and after the modification to compare the results. And relative results assume greater importance than the absolute ones during the development. Mustafa, can you just share with us some ways how we can integrate performance in this development stage?
Sure. So performance unit testing is one of the important activities while achieving the continuous performance management. Often, developers' focus is on writing code and implementing features. They seldom care about the performance of their code. Now, performance unit testing is one of the differentiators that addresses lots of limitations of the traditional approach that we referred earlier. The focus of the developer changes from delivering just the code to delivering optimized code. They are expected to test the code for their performance and identify and fix any bottlenecks at the code level. Performance unit testing is very similar to the JUnit testing, but instead of functional errors, the focus is to identify the performance errors. These units can be automated and integrated with nightly builds for automatic execution. Further, the integrated profilers can also be used to monitor the CPU and memory behavior while these units are running. These can help in identifying the slow running methods or queries and help in optimizing the code. Now, the question comes that how do we create these performance units? Because developers are quite hesitant in using the full-fledged load testing tools in their development environments. The concern is the systems might get slow or they would have to do lots of configuration. But there are lots of tools that can ease this process for them. Tools like Solix and Performance Workbench can be easily used for this purpose. On your screen, you can see a sample of a recorded test script using Performance Workbench. This is an Eclipse plugin that allows developers to record test scripts and run it with few users to test the concurrency of the code they are developing. This also gives them a chance to measure the performance and identify any issues. And there is no need to go away from their development environment. It all gets integrated into a single place. The next way of creating performance units is using JUnits as performance units. Now, this also avoids any recreating of new scripts, and JUnits can be easily used. Frameworks like punit or JUnit Perf can be used for this purpose. Even traditional unit testing tools like JUnit and TestNG have also come up with plugins to support concurrency testing. On your screenshot, you can see a couple of JUnit samples that we created using the punit framework. These frameworks allow these JUnits to be executed by multiple users and also for a sustained duration. This helps in analyzing the memory and CPU behavior for these units. Next, as I mentioned, these units can then be integrated with automated systems and regular test reports can be generated. As you can see on your screen, a snippet of a sample report which shows that what test units were executed and what were the timings of each of these. These reports can then be further drilled down and to go to the bottleneck method or query. Over to you, Lisa.
Thanks, Mustafa. Let's now talk about testing. The Continuous Performance Management, or CPM, provides the benefits of build automation and faster deployment for the execution of performance unit test cases and load and stress testing. In Agile projects, the teams mostly rely on continuous integration systems that generate and deploys intermediate builds at periodic intervals. And the same can be leveraged by the performance engineering team. A secondary build after code verification can be configured to execute performance tests and automated profiling of the code. Execution of performance unit test cases on the integrated builds along with automated profiling really helps to track the API and memory allocations of the application components. Mustafa, I'm going to go to you one more time, and can you just tell us what tools and frameworks you can use here?
Sure, Lisa, not a problem. Testing is an important phase in the entire SDLC. This is the phase where the system is ready and integration testing starts. This phase marks the beginning of end-to-end testing where all the underlying components and tiers of the application are exercised and measured for performance. The performance test scripts are created at this stage, or if performance unit testing is used, the earlier created test scripts can also be used. Performance testing and diagnostic tools like JMeter, SandStorm, Dynatrace, Diagnostics, Glassbox can be used at that stage. The objective is to identify the bottlenecks and fix those. These tests can be added to the continuous integration servers for the automatic execution. This provides an automated framework for the execution of performance tests and the result generation. You can see on your screen a sample Hudson screenshot where we have used a JMeter plugin to integrate the entire performance testing suite with our CI server. Hudson provides rich features and capabilities to integrate with JMeter as a load testing tool. You can see that this gives us a benchmarking and a result comparison for performance between different releases. At a glance, we can see how our releases are comparing in terms of performance and where the problem crept in. Next, you can see a detailed report which talks about what kind of metrics are reported by a plugin load testing tool. Now, imagine that if your tool can automatically trigger your performance test, generate the reports, publish it to the dashboard, then how much of your work is taken care of. These reports can be automatically notified to the concerned team and they can have a look at this and take some actions. That's the advantage of implementing CPM that we can have. Now, let's take a look at the holistic approach of achieving CPM across the SDLC phases. One of the important phase that is again forgotten by most of the team is the post-deployment phase. This is the phase where applications are deployed in production, but the CPM doesn't end here. It also says that post-production monitoring mechanism should be in place to correct the production data for monitoring. This data can then be used for trending or forecasting or coming up with capacity models to help in coming up with your infrastructure capacity for future workloads. Lisa, can you take over?
Thanks, Mustafa. Those are some great examples. Now we're going to see how CPM can be used in Agile Environment. And since Scrum is the most popular and widely used Agile methodology, we're going to show you how we can achieve CPM in Scrum. Performance engineering, when executed using the Agile model, becomes an iterative and collaborative process. Let's see now how performance engineering activities are carried out during the different phases of Scrum. The first phase concentrates on capturing the non-functional requirements of the application that's being developed. Performance engineers would spend time interacting with the business owners, really understanding the business domain, identifying the performance SLAs and objectives for that release. Now, once armed with all this information, the overall performance test strategy for the application is created. The performance engineering tasks are identified and added to the product backlog. The test scripts and scenarios, as well as the system architecture, will all be based on this information. Now, this phase is pretty similar to the sprint pre-planning in Agile development. It requires close collaboration between the product owners and the business teams to define the performance objectives for the application. Now, the typical performance engineering tasks in product backlog can range from architecture and design review to designing the test scenarios. They would also include creating test data sets, test execution, profiling, as well as fixing identified performance issues. Moving on to the next phase, which is very important because this is where the actual execution begins, and it's called Sprint in Agile. We now have to choose between the two ways to integrate performance engineering with Sprint. First, that the performance engineering activities become a part of the product backlog and the performance engineers become a part of the sprint. Alternatively, we can have a dedicated sprint running, a separate product contained while the performance sprint runs in parallel with the development sprint. Now, depending on the number of team members and locations, either one of these options can be selected. But what's essential here is that the performance engineers become a part of the sprint team. While the developers work on the user stories from the product backlog, the performance engineers will work on the test strategy for these user stories. They would focus on the tests that can be executed to measure and track the performance of the feature during its development. These focus tests are executed in a dedicated test environment and usually provide really valuable feedback during the early stages of the development lifecycle. The tests also give the development team enough time to resolve any performance issues that they might see, as well as alter the design and architecture if that's what's required. If any external dependency is required for testing the component, appropriate stubs and simulators can be created by the performance engineering team. The architectures are redefined and re-engineered based on these assessments and performance results. Another important activity here is to ensure that the system is properly tuned and that the results are meaningful. The performance tuning and troubleshooting should be iterative processes where you make the change, run the test, analyze the results, and then repeat the process based on the findings. The last phase in this process is the sprint closure, which marks the end of the development and deployment phases. The system is now completely developed and deployed in production with the performance monitor for data collection, forecasting, and capacity planning. Now, I'd like to just take a moment and ask you all a question. We want to know what, according to your experience or opinion, is the biggest challenge to implement CPM in an Agile environment. Your options are A, unavailability of suitable tool sets, B, lack of expertise, C, time crunch, or D, all the above. And you can answer that question on the right of your screen right now. Okay, it looks like we have some mixed results from the audience. The majority votes, however, look like they're indicating that unavailability of suitable tools as well as lack of resources, expertise, are the biggest hurdle. Mustafa, what is your take on these poll results?
Lisa, to be honest, I was expecting such a response from our audience. we have seen based on discussions with various teams across different customers and domains that they do not have much awareness about CPM. One of the reasons would be the lack of awareness about different tools and technologies that can be used for this, or there might be a lack of expertise in these tools. But there are tools available both commercially as well as open source that can be used to achieve CPM and also implement an automatic performance testing framework as per your own requirements. And I am sure that our audience would have heard about most of these tools during our webinar.
Great. Thanks, Mustafa. So, having shared with you how you can implement continuous performance management in your SDLC and in Scrum, I'd like to quickly share with you some key benefits of CPM. The first one is that CPM can be applied to both new applications being developed and the enhancement of existing applications. Addressing performance engineering with an agile, iterative manner helps in meeting product performance goals faster and just more efficiently. Another key benefit is that we can quote here is that it reduces the time to market. Since the application performance has been tracked throughout the development, the product release would not be interrupted due to any performance issues. CPM helps increase the ROI due to its extensive focus on automation. Thereby, it reduces the human intervention and errors that might be associated with it. Since CPM emphasizes the performance unit testing, it also helps in measuring and improving the performance at the atomic level. And now I'd just like to take a few minutes and share with you a couple of real-world examples where we have successfully achieved continuous performance management for our clients. Now, in the first example, in this case, the client is a leading provider of digital mailbox solutions in the U.S. We were engaged to design a large cloud-based solution for the end users, and one of the key requirements during the development was to come up with a continuous and automated performance framework. Impetus first set up a team of performance architects and engineers to define and implement a continuous performance management strategy. The team started with capturing the non-functional requirements during the initial design phase of the application. Now, this involved defining expected user and transaction volumes, user concurrency, and interfacing with the third-party systems, and so on. Since the application was to be deployed on the cloud, we decided to create the performance testing environment on the cloud itself for just a realistic simulation of production usage. During the development phase, the development team was encouraged to create performance units and test the performance of web services in their environment. A continuous integration environment was in place to create builds and check the stability of the code. All the unit tests were automatically triggered during the nightly builds, and the concerned team members were actually sent notifications in case there were any errors. During the integration testing phases, the end-to-end test scripts were created using JMeter. The JMeter plugin was used to integrate the test executions with Hudson and also populate the corresponding dashboards with the test results. Now, during the integration builds, automated scripts were triggered to provision the performance testing environment over the cloud, install and configure JMeter, copy the scripts, and start the test execution. I have to tell you that our client was really happy to see the entire build automation and integration with PE activities. Now, since we primarily used open source tools for this activity, it also spells significant cost savings for the client, which is always welcome. Also, the development and integration cycles were shorter because of the automation. Performance issues were able to be identified early in the development cycle, and as a result, didn't trouble us during the production. And now on to our next experience I want to share. Now, in this case study, the client was a leading provider of workforce management solutions across the globe. Impetus has actually been their performance engineering partner for almost 8 years. Our client here wanted to set up an automated framework for performance regression testing on the release candidates. This framework was required to automate the test execution and result generation. The offshore performance engineering team worked in close collaboration with the client team to define the requirements for this automated framework. Now, based on extensive research and POCs, the team selected STAFF, an open-source software test automation framework, and SandStorm, Impetus's flagship performance testing tool to use for this project. The on-site team was responsible to automate the application installation and prepare the test environment, whereas the Impetus team worked on the performance testing automation. We were able to customize SandStorm to support this integration. The command line interfaces were provided for test execution and result generation, and all the test scripts were automatically copied to the load generators before execution. Now, to further save on time, the team automated the process of creating the test scripts using a freeware called AutoIt. The on-site and offshore teams use this framework for running the performance regression suite for the target release. This framework helped significantly shorten the performance testing execution cycle. The test environment was optimally used because the test could be scheduled at night or at odd hours throughout the day. And because of this, the efficiency of the teams increased due to this automation. The process became mature and less susceptible to any errors, and it also gave the teams enough bandwidth to focus on performance tuning and optimization. Now, before we sum up today's session, I'd just like to quickly introduce Impetus's SandStorm, which is the automated performance and load testing tool. SandStorm enables multi-protocol testing of environment applications that demand high availability and responsiveness to the customer. In fact, SandStorm will soon enable leveraging cloud infrastructure for automated performance testing in its new release. Now, currently, we deploy SandStorm controller and load generators on cloud and use it to conduct high-currency performance testing for internet, mobile, and intranet applications. SandStorm also supports and facilitates performance-centric development and can help you achieve CPM. It has a plugin called Performance Workbench that helps the developer to create performance test scripts and unit test cases from their IDE, such as Eclipse. Now, these test scripts can be run using CI for automated execution. SandStorm can be triggered from ANT scripts that allow it to seamlessly integrate with nightly builds. So let's go over now what we've covered in today's session. The majority of enterprise applications just fail to meet their production performance requirements. A real change is needed across the development, testing, and deployment operations within the organizations to resolve these failures. The most constructive and effective change that an organization can make to this address performance at the application level as early as the development lifecycle as possible. This includes defining service-level agreements in architecture artifacts, such as use cases, as well as a proactively monitored performance during the development of the application itself. Continuous performance management aims to eliminate application performance issues by automating application performance tests several times a day in a continuous integration environment. By ensuring application performance at every step of the development process, countless days, weeks, and even months can be saved in diagnosing production performance issues. Now, it's a common misconception that achieving CPM is risky and time-consuming. In fact, it saves a lot of time and effort in the long run. Plus, it emphasizes the efficient use of automation tools and frameworks. But before we move on to the questions, I would like to take this time to introduce Impetus Technologies to our audience. Impetus provides and offers product engineering and technology R&D services to technology companies and ISVs. Our expertise spans the domains of performance engineering, cloud, testing, large data management, data analytics, mobile, SaaS, and social media, among others. We really offer a holistic approach to performance improvement across the entire software development lifecycle. We assist organizations in optimizing their system operations and provide high-performance planning, testing, and real-time performance monitoring services. We also help companies resolve a host of performance-related issues and define SLAs for applications. Okay, so it looks like we have our first question here for Mustafa, and that question is, how can we create performance units? Mustafa?
Yeah. So performance units can be created in two different ways. One way, either we record the entire test script from the development environment in using the IDE. Tools such as Solix and Performance Workbench can be used for this purpose. These tools provide inherent capability to integrate into environments like Eclipse and provide the development team the power to create test scripts and execute with some number of users. On the other approach would be to use existing JUnits for performance unit testing. For this, PUnits or JUnit per frameworks can be used to convert your JUnits into PUnits and execute those.
Okay, great. And we even have another question. These are great. This one asks, what are some typical challenges in achieving CPM? Mustafa?
Yeah. So again, if we look at the benefits of CPM, then it is really good to achieve a CPM, but on the other hand, there are few challenges that are faced by teams when they start adopting CPM. One of the important challenges is the lack of awareness about tools that can be used to set up such a framework. Next, the lack of expertise is another challenge that is faced by most of the teams. Teams are not aware that there are lots of open source utilities like Staff, which is an excellent open source framework that can be used to create a custom framework for automated performance testing.
Okay, we've got one more question. This one just came in, and someone would like to know, can the performance unit testing tools scale? Mustafa?
Yeah, so performance unit test tools are inherently meant to support low concurrency tests. Basically, these tools are used in the development environment. So these are meant to run with low number of users and to get some initial performance numbers that how the code is performing. But in case the development environments are really highly configured and they can be used as test environments, these tools can help you to scale to a large number of users and provide numbers for these executions.
Okay. We've got another great question that just came in, and this one would like to know, how would you define load, stress, and performance testing, and how do these fit into your use of phrase performance testing?
Okay, so this is again a good question about different testing methodologies. So load testing, the purpose of load testing is to generate load on the system and measure how it performs. The load can vary up to a given extent where the system breaks, while the stress test tests the systems above the breakpoint of the application. Let's say if your application is only able to handle 100 concurrent requests, so your stress test would go beyond 100 and see how the system can handle this additional load, while the performance test would just measure the performance under a given criteria. So you would get some production usage and set up your test scenarios to measure the performance of your application. All these tests fit into the testing phase of our SDLC. This is the phase where the system is stable and ready to support this multi-user testing for a large concurrency. The low volumes of such tests can be executed in the development environment, but it would be more of a concurrent performance unit testing rather than the stress testing.
Okay, it looks like we have one more question to cover right now, and this person would like you to please repeat the tools available for performance unit testing. Could you do that?
Sure. So the performance unit testing can be achieved using Solex or Performance Workbench. So these are the UI tools that help in creating the end-to-end test scripts. On the other hand, tools like PUnit or JUnit Perf can be used to leverage existing JUnit test cases as performance units.
Okay, thank you so much. Those are some great questions. Thank you all so much for submitting those. We just want to thank everybody for joining us today for this webinar, and we really hope that this discussion was a learning experience for everyone and will add value to your performance engineering initiatives. If you have any questions, please feel free to email us at inquiry@impetus.com or go ahead and visit our website, www.impetus.com. Once again, thank you so much for joining us in the session today. Goodbye.